Hey guys, welcome back to Paraclete TV. Today we'll be talking about congruent angles and solving for missing angles and adding, subtracting, and looking at angle relationships. Alright, let's get into it. Okay, so the most basic example you're going to find for looking at the relationship between angles is two parallel lines intersected by another line going in another direction. This is a great example because you can find a lot of angular relationships between different angles in this example. So first off, let's just talk about this angle right here. Right? It's the angle between one parallel line and the line that is slicing the lines. We're going to denote this as angle A. Now angle A is clearly less than 90 degrees. Though if it wasn't drawn to scale, it could be larger than 90 degrees. But opposite over here, we have angle B that is larger than 90 degrees, right? Because it looks larger than a right angle. And something that we know is that A and B are supplementary angles, meaning that they add together to be 180, because this line here is 180. So this angle plus this angle must be 180 because it has to add up to 180. Given that, a relationship that we also know is opposite angles. So angle A's opposite angle would be here. See how it's directly across? Not down here, because this angle plus this angle also has to equal 180. So this is going to be A, and this is going to be B. Because directly across from the transverse line is going to be the right angle. And then we can check and say, well, if this angle, like over here, the parallel line was 180, if this angle is also 180, then these angles have to add to 180. And like we said before, A plus B equals 180 degrees. A and B have the relationship of being supplementary angles, meaning they add to 180 degrees. Okay, now let's move down to these angles down here. Because these lines are parallel, this portion intersects this line at the same degree and at the same angle that this portion will intersect this line. So we can think of this as a completely new line, but we don't really have to, because we already know we're going to mirror what's up here down here. So this angle A is going to be right here. This angle B is going to be right here. And then, from what we know before, across the line, this will be B, and this will be A. So when a line is cut by another line, or an intersection of lines, we can tell a lot by the angles. Because we know that when angles are on a straight line, they have to add to 180, or when angles are on a right angle, they have to add to 90. And we also know that opposing angles are always equal. Okay, so we know that the definition of supplementary angles is add to 180 degrees. There's also a relationship of complementary angles that add to 90 degrees, and I'll give you an example of that. So in a lot of shapes, like a square or any rectangle, that's a terrible square, we know that the angles on the corners are 90 degrees, right? So if we were to have a line go through the square for some reason, we know that these angles here are complementary because the sum, the larger angle that isn't cut, is 90 degrees. So we'll say this is C, this is D. C plus D equals 90 degrees, and they're complementary. This is very helpful when you're trying to solve triangle angles and even square angles. Alright, so just a little quick summary of the video. Congruent angles are angles that are the same. So like we learned in the parallel line example, or any example of one line intersecting another, we can tell what angles are by symmetry. So we know that this angle here, dash 1, is going to be equal to its equal and opposite partner across on the other side. So those two angles are equal, and then we know that these two angles are equal because of the same principle. So the red angles are congruent and the purple angles are congruent. Thank you guys so much for watching this video. I hope it helped, and I'll see you next time. Thanks!